Welcome back to another devlog. You may remember that in the last one I had discussed the wibbly plasma effect that I used in the console lettering on the title screen. Now, I only had time to talk about the actual plasma effect in that video, and I promised I would cover the cookie cutter masking technique in the next one. Well, here I am to do just that. I think the best thing to do is to just dive in and look at the sprites I'm using and the object code. Now, we'll need to take a quick detour into blend modes at some point, but we'll cross that bridge when we get to it. Okay, so we have an object in our title room called Object Title Graphics. You see it down here. Now, this is assigned a sprite called Sprite Title Graphics. That's the one you can see here. This sprite is the lettering, consisting of an inner purple region, which doesn't move or anything like that at the moment. It's got nothing to do with our plasma code, and it's also got a thick grey outline. I also need to point out this other sprite called Sprite Title Graphics Plasma Mask, which only has the inner purple part. It's not got the outer grey part. It's important to note here that the pixels that you can see, the purple, have alpha values of 1, whereas everything else is transparent, which means the alpha value is 0. But the purple areas, where the alpha is 1, is the area where we're going to want to draw our plasma effect eventually. So these are just the sprites. Let's have a look at the code in the draw event of the object title graphics to see how these are actually used. The first line is draw self. This just draws the currently assigned object sprite in the normal way. Now the object sprite is this one with the grey outline. So we just get our console lettering drawn with the purple inner bit and the grey outline. So far so normal. The next set of lines get a little more complicated as we're setting things up to go and set the alpha values of our screen surface to 0. So that's this section. Let's look at these in turn. GPU set blend enable false will turn off all the alpha blending maths. So anything we draw now will just be drawing the source directly over the destination, just as it is. This GPU set color write enable is telling the GPU that it's not allowed to write into the R, G or B channels. It can only write into the alpha channel. These arguments here apply to each channel. So that's R, G, B, alpha. Alpha is the only one that's true. Alpha is the only one that's allowed to write into. Draw set alpha is telling the GPU just to set the alpha to 0 for all the draw events. And then draw rectangle 0, 0, room with room height, and false is just drawing a rectangle over the whole screen. Now remember, at this point we've told the GPU not to alter any of the actual colours, the RG or B, only the alpha channel, and that has to be 0. So the entire screen surface pixels have their alpha values set to 0, when usually they would be 1, but we want them to be 0. The next couple of lines are draw set alpha 1, and then draw sprite. Sprite being the plasma mask this time, which is this one. Here we are telling the GPU to reset the default alpha drawing back to 1 as normal. Then we're drawing a sprite, the plasma mask without the grey outline like we noted, but we haven't re-enabled the colour writing yet, and so the GPU will still only be affecting the alpha values in the destination being the screen. So following this, the screen surface pixels will have alpha values of 1 only where they were 1 in the plasma mask, i.e. the purple bits of this sprite. Everything else is set to 0 in alpha because we drew a huge rectangle of 0 over everything. The next couple of lines are GPU set blend enable true, GPU set color write enable true, 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 true. Here we're just turning alpha blending and the color writing back on. Everything so far has been to set up our screen alpha the way we want. Essentially we're setting the screen alpha to 0 everywhere except for where we want to be able to draw our plasma, and that's the purple bits in our plasma mask. The next part is to draw our plasma into those parts of the screen where the alpha is now 1. So we need to set up a particular set of blend modes to do this. These will use the destination alpha rather than the source alpha. Remember, the destination is the screen surface, and this is where we've gone to great trouble to set the alpha just the way we want it. So the next line does this. GPU set blend mode BM dest alpha BM inverse dest alpha. At this point I'll take us on that detour into blend modes that I mentioned earlier. And this is the kind of mathematical techie bit. When we draw something on screen, the GPU is actually doing the following calculation for every pixel. The final pixel colour is the source times the source blend factor plus the destination times the destination blend factor. Ordinarily, the source and destination blend factors are set to depend only on the source alpha, but we've told it to use factors which depend on the destination alpha instead. That's what we're doing by specifying these dest alpha related arguments here. Okay, I've switched over to using my trusty tablet here because basically I never use it and I just want an excuse to use it. So let's have a look at what happens with these blend modes then. So what have we got? Currently we've got a screen, the pixels, some rough looking pixels, and we have gone and written into the alpha values where we want to be able to draw and where we don't want to be able to draw. Remember, we set the alphas to 0 in all the pixels on the entire screen, and then we drew our plasma mask sprite, or the alpha from it anyway, into the pixels where we do want to be able to draw our plasma. Now, if you recall, the GPU is doing this kind of calculation where the final pixel color is the source RGB times the source blend factor plus the destination RGB times the destination blend factor. Now in this case, the source is our plasma texture and the destination is our screen, this one. Let's have a look at the case where we have a pixel on the screen with an alpha of 0. So in this case, the destination alpha, that's AD, equals 0. The final pixel color is going to be equal to the source times by 0 plus the destination times by 1 minus 0, which is just 1, which is going to result in, that'll cancel out and that'll just be 1. So it's going to be our destination. Remember, the destination is the screen. So in this case, the final pixel is just whatever the screen was in the first place, and that's what we want. This is alpha 0, we don't want to be able to draw there, and so we haven't. It's just ended up the way it started. Right, so let's have a look where the alpha in the destination is 1, so that's these purple squares, these purple pixels. So in this case, the final pixel color is going to be the source times by 1, destination alpha is 1, plus the destination times 1 minus 1. Obviously that's 0, so that just cancels out. We're just left with S, the source. The final pixel is going to be whatever the source was, and the source, remember, is our plasma texture, so this pixel will get written into. And it does that for each one of these pixels when it's drawing. Hopefully that made sense. Okay, we'll go back to the code then. So the next few lines is where we actually draw the plasma. shader set show plasma is telling the GPU to use the plasma shader that we made in the last devlog instead of the default shader. If you recall, this shader completely ignores the sprite data that's given and uses some maths to make the wibbly plasma effect instead. The next bit, shader set uniform, you can basically ignore it for this devlog. This command is how we pass the time into the shader to make the plasma move about. You can look at the previous video to see how this is actually used by the shader. And draw self is where the GPU actually goes and does the drawing process using the plasma shader and the blending process that we just went through. Everything up to this point has just really been doing setup. The draw self is where the magic happens. Shader reset is just telling the GPU to discard the plasma shader and go back to using the default shader or whatever it was using previously. If we didn't do this, then the GPU would continue using the plasma shader for every sprite draw from now on, and everything would end up looking like a plasma. Obviously, we don't want that. The last couple of lines are also for resetting alpha test and blend mode behavior back to normal. And that, I think, brings us to the end of the devlog. I would have liked to have just pointed you to the original Game Maker blog post for this, but it seems to have been removed for some reason. Hopefully you've been able to follow my explanation, including the rather convoluted sort of maths that we just went through, and maybe you can use it in your own projects. Thanks for watching, if indeed you have, and I'll see you in the next one.